Guys, we're going to do two things today. We're going to do the shortcut in case you missed the shortcut, and we're going to do the dot diagram. So if you already understand the shortcut and you know about the exceptions, you might want to fast forward it until I get to the dot diagram. So whichever. We're going to review two things, and that is the dot diagram and the shortcut. First, we're going to talk about the shortcut. When we did the electron configuration the long way, we started with element number 1 and we would read through the periodic table until we got to our element. The shortcut allows you to start at a different spot, a shorter and quicker way to do it, and then go from there. So where we're going to start with the shortcut is over here, the noble gases. They're called perfect, so we are going to let those be our beginning part. So if we were doing, for instance, if we were trying to do strontium here, now it would take a minute to go 1s2, 2s2, 2p6, 3s2, 3p6, and if you don't know that part, you need to back up and see the other video. So strontium, what we're going to do is we're going to look and find the nearest noble gas that is to strontium without going over strontium's atomic number. The nearest noble gas to strontium is number 36, krypton. So what we're going to do, so I'm doing strontium, you back up to the nearest noble gas, and we're going to be putting krypton in brackets. What that means is you're saying ditto everything up to krypton. So rather than writing all of krypton's electron configuration, 1s2, 2s2, etc., we just put it in brackets. So that's a ditto mark for krypton. And then you go forward. So we're at 36. We're going to go through 37 and 38. And there's the 5, meaning this is the 5s2. And that is the shortcut electron configuration for strontium. You can make sure you did it right by taking krypton's atomic number, which is 36, and adding what we added to it, which was 2, and that will get us 38. I'll give you another example. If I wanted to do xenon, I don't want you just to put him in brackets, even though he is a noble gas. You would back him also up to krypton, and you would go forward, and this would be 5s2, and then you would go here into the D's. This would be 4d. We're going through all 10 boxes, and then we'll go through here again. We're starting back to 5. This would be 5p, and then we count 1, 2, 3, 4, 5, 6. And that's the shortcut electron configuration for xenon. Alright, we're going to do couple more, and then I'm going to talk about the exceptions. Okay, so if I were wanting to do mercury here, which is number 80, it would take me a while. We're going to back up to xenon. We're going to go forward, so we're at 54. We're going to go forward. We would go through these two, which is 6s2, and then we run across this little line. On your quiz or test, I'll give you a periodic table that doesn't have this little line, but it's got a star there instead. So you're going to see a star over here, you're going to see a star down here. If you'll notice, it goes 56, and then it jumps all the way to 71. The reason it jumps is because these 14 have been taken down here, so I need to include them. So this would actually be 4f14. And then I come back and we're going to count this, the rest of this row. And this would be 5d. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's mercury. Okay, so practice that. I do have a worksheet, a practice worksheet for that. So if you don't have it, please come by and get it. Alright, we're going to talk about 5 exceptions. I'm going to highlight them. I suggest you highlight them on your periodic table as well. It's chromium and mobilium, and copper, silver, and gold. So these are your 5 exceptions that you need to know for your quiz and for your test. So I'm going to do chromium. I'm actually going to do chromium the shortcut way. If I would back up, he's going to back up to, whoops, don't want to be in highlighter mode. back up to argon, and we would go forward. This would be 4s2, we would think, and 3d4. This is this one. It's what we think he is. He's really not that. We're going to talk about what he's not. These 5 all follow the same exception. They don't play by the rules. They're an exception for one reason. On all these exceptions, you take 1 away from the s. So this is going to become s1, and this goes up by 1. s1d5. They think it's more stable for this to be half-filled and this half-filled than this one be completely full, the s's that is, and the d's to have 4. So you take 1 out of the s and put it in the d, and that's what you would do on chromium, and you would do on beryllium. This one actually would be 5s1, 4d5. So let's do gold here. If I were doing gold, you would think that it would be xenon in brackets, and then we go forward, we get 6s2. You run into that little thing which tells me to go down, 4f14. Now back up here, and we are at 5d9. That's what we would predict for him. What we know happens is 1 comes out of the s, so this actually goes to 1, and this goes to 10. Notice I didn't mess with the f's whatsoever, so it's always the 1 out of the s, putting it into the d's. And those are the exceptions, so you need to know these 5 for your quiz and your test. Even in the long way, I'm going to do chromium, long way, he would be an exception. You'd have 1s2, 2s2, 2p6, 3s2, 3p6. We would think it'd be 4s2, 3d4. This is chromium, but what really is, this is a 1, and that's a 5, because it is an exception. Okay? So now we're going to do dot diagrams. If you're a band student, we are doing dot diagram now. What a dot diagram is, a diagram that shows valence electrons. And you should have learned valence electrons some other time in your career, but what a valence electron is, that you might want to write this down. A valence electron is the electrons in the outermost energy level. And the reason they're important to us is because those are the ones that are involved in chemical bonding. So that's what's making them special, why we're wanting to zoom in and look at them. They're the ones that we're going to be talking about when we start talking about bonding. We'll be looking at valence electrons. The way we do a dot diagram, which is actually called a Lewis dot diagram. It's actually called a Lewis dot diagram. Is you take your chemical symbol, such as if you were, we'll just make up, if you had a chemical symbol X, please don't look for X on the periodic table, you won't find it. You're going to be putting dots around them to illustrate the valence electron number, and you will have nothing more than 8. So if you ever find yourself putting more than 8 dots, you're doing it wrong. I don't really care exactly where the dots go, but for simplicity's sake, we are going to put a dot here if it's 1. If it's 2, it'll look like this. At 3, you can start going clockwise, or you can do counterclockwise. There would be 3, 4, 5, 6, 7, 8. When I said 4, actually, carbon, which has 4, looks like this. So 4s we actually spread out. So I don't really care about the others as long as you spread out. One thing I don't want you doing is like this. Okay, it's a 2x2 fashion around the symbol, and you actually use the symbol of your compound. So I want to show you carbon, since I've got him sitting up here. Carbon's electron configuration is 1s2, 2s2, and it's 2p2. Okay, it actually has a valence number of 4. And where am I getting that? Is the biggest energy level here is the second energy level, and in the s's there's 2, and in the p's there's 2. 2 plus 2 is 4. That's the valence number of carbon. So if you'll notice, it's always going to be s's and p's. Let's look at if we were doing fluorine. Fluorine is 1s2, 2s2, 2p6, 3, oops, excuse me, I went a little too, I was doing chlorine and not fluorine. He has 2p5. His valence number is 7, so you would have F, and you would have 7 dots around it. Make your dots where I can see them. Don't put, I was getting a little lazy there. Make your dots where I can see them there. So let's get one that has like D's and stuff in it. If I were doing vanadium, I'm just going to look at the shortcut of vanadium, letter V. He would back up 2 argon, and then we would go forward to 4s2, and then he would be 3d3. Our largest number is here. Notice it's always either going to be S or P. There's no D's involved. This is 4th energy level. That's 3rd energy level. So vanadium would actually only have 2 dots. And if it has 2, we typically write them to the right of the element there. But if you did this, I'll be okay with that as well. Just don't put more than 2. We wouldn't put 5. That's 3rd energy level. That's 4th energy level. So basically, you're just going to be adding your outer S's and P's, or looking for the biggest, what we call principal quantum number, and adding your S's and P's together. So if we go back, and when we look at, this was chromium. Here's my biggest number. See, these are all smaller numbers. Biggest number, and I changed that. So chromium would actually have just 1 dot. Let's see if I got any more here. Nope. I've erased the others. So you could practice that, but let me even show you an easier way. It gets easier than that. I mean, you just look at your S's and P's and add them together, the biggest one. Everything in this first family, known as the alkali metals, they all end in S1, so they're all going to have a valence number of 1. These all end in S2. They're all going to have a valence number of 2. Skip these guys here. These all end in S2P1. These are all going to have a valence number of 3. These are all going to have a valence number of 4, 5, 6, 7, 8. Can you see these numbers that are with these A's here? That's the valence number. The A's are the main group. I skipped the guys in the middle for a second. That is their valence number. Now 8, it counts for neon down. Helium only has 2, so he would be He with 2 dots. But say you were doing sulfur, since sulfur is right here in the 6, it'd be S with 6 dots around it. Something like that. So if you can just look and see. So what's going on with the middle? Well, I just did vanadium. Vanadium had 2, and then I did chromium, but chromium has 1. Most of these guys in the middle have 2. Your exceptions all have 1, such as silver would be just 1. If we drew him out, you would see we took 1 out of the S, put it in the D, and the D is 1 less number. So the dot diagram is very easy. If I'm doing calcium, he's just going to be Ca with 2 dots. If I do iron, it's going to be Fe with 2 dots because he's not an exception. If I do xenon, it's going to be Xe with 8 dots. So those little numbers up there, I will tell you the pink periodic table does not have those numbers, so you need to know it's 1, 2, 3, 4, 5, 6, 7, and 8. Helium only having 2 because he only has 2 electrons. So that's the dot diagram. On the review sheet, it has you do the electron configuration and the dot diagram on your test. I'm going to have you do the dot diagram as well. So make sure you're able to do the dot diagram. We are going to take and go and do some more interesting things with the dot diagram. So Anyway, that's pretty much a review of the shortcut and a very quick lesson on the dot diagram. Hopefully this will help you. If you do not understand, please come in and see me.